Okay, I'm going to go through a Moreton Bay case study. Moreton Bay is an embayment next to the city of Brisbane. It's on the east coast of Australia. Brisbane's capital, Queensland. It's the Great Barrier Reef stretching towards the tropics up here, north of Sydney. So a few environmental literacy principles on Moreton Bay. It's shallow, it's productive, it's formed by large sand barrier islands. It's got extensive seagrasses which support turtles and dugongs. It's got a big watershed with lots of ephemeral streams. It's vulnerable to gully erosion that creates sedimentation. It has a rapidly developing watershed, big population pressure. It's the equivalent of a sun belt. It's got extensive blooms of a benthic cyanobacteria that we were able to link to land use changes, humic runoff, and human health impacts. And it has a large campaign, Healthy Waterways campaign, stimulating research, monitoring, management, and research. So here's a conceptualization of Moreton Bay. You see that it doesn't have horizontal stratification like Chesapeake Bay with the dead zone below. In fact, it's got vertical stratification, and that has to do with the good tidal mixing and then the pulses of fresh water nutrients and sediments that come in occasionally from the catchment. The estuarine zone is where the sewage treatment effluent is discharged. It's also where the stormwater enters. It tends to be pretty brown water color, giving way to the greener water that's where the sediments drop out and the phytoplankton takes off, and then into the marine environment with good adequate flushing. You see the dugongs, turtles, and seagrasses over in the eastern part, and corals. These extensive seagrass beds grow on these flood tide delta in particular, next to what they call South Passage here, and these support about 1,000 dugongs and 10,000 green sea turtles. And the seagrass beds, much to my amazement, and when I first arrived, I was walking along thinking we're going to go see some seagrasses, and I kept walking and walking. When are we going to get there? And they're going, mate, you're already there. And that's because the seagrasses are so extensively grazed by turtles and dugongs that the bottom looks white, sandy, and bare. It's most of the biomass is underground. The watershed has an extensive network of ephemeral streams, and what we call a stream often isn't wet for 360 days a year. So there are a few places where we have some standing water, but a lot of times it's just a depression that's full of grass. And a couple times I was looking for streams and I walked right across it without knowing I was on the stream. And it's connected to the rivers and estuaries, which are very prone to flushing. This is a picture of downtown in Brisbane over a couple of the major flood events, the most recent in 2011. Before that, 1974, and the big one in 1893, and even the buildings have little plaques denoting where the floodwaters reached to, and this was during one of the flood events, and here's a restaurant, which was a floating restaurant, which broke loose and was drifting down the river in 2011. So this watershed is very vulnerable to gully erosion, and it turns out the type of erosion that occurs is the type where it's incising the stream, the banks of the stream, and we determine that with some isotope analysis. So cesium and radium, and the ratio. Cesium is derived from the bomb fallout from nuclear testing, so it's on the surface sediments, and then the radium is generated with the uranium decay series in the sediments itself, so that's from underneath. And what you see here is that that most of the sediments are derived from areas that have been disturbed, cultivated, as opposed to natural forested areas. And so in a couple of sub-watersheds, we see where the source is, and it's very strongly related to the mud that's out in the bay is strongly related to these two source terms, the Marburg and Walloon formations. And when you go out and look at those areas, and you can see this erosion, you can see these street banks in size like 10 feet down, and it's mostly because they allow cattle to go in and graze that, very dry and arid for much of the year. There's not much grass to protect it, so the stream, when it does rain, the stream just cuts away in the sizes of the stream banks. It ends up in this patch of mud out in the bay, and here's the suspended sediment concentration from a model run during a flood event. And then these are actual measurements of the percent mud in these cores across the bay. And what you see is all this mud ends up in this big mud patch. And then it's very sandy outside of that big mud patch. The problem with that mud patch is that it causes resuspension. And because there's about a 2-meter tide and sea breeze in the afternoon, every tide and every wind event resuspends that sediment, and the wind is coming from the prevailing winds or southeast, so or northeast in the summer. So either way, it concentrates the suspended sediments on these coastal embayments within Moreton Bay, and that's where the seagrass loss occurred historically. That one was in 1996, and this was even more recent. So that's caused some problems. So this is the area that I mentioned was the Sun Belt. This is the 1880 footprint, very small. It was founded, all of Australia is much younger even than the U.S., and it grew after World War II. MacArthur was stationed there during the war after he got kicked out of Philippines, and then, of course, went off to regain the Philippines later. Here's 1991. So during the decade of the 90s, it was the 4th fastest growing region in the world. And the riverfront very much transformed. I call it the Dark Ages versus the Renaissance. In the Dark Ages, it was it was the backyard of buildings and houses, and now, of course, everybody wants a river view, and it's on the front yard. There were dredges that were actively getting sediments out of the river for the sand and gravel mining for construction, and now it's pleasure boats and city cats. These high-speed ferries, very popular. Lots of garbage just tossed in the river. Industrial development. Now there's a bikeway on both sides of the river for 20 miles on either side, and very popular parks. The sewage was partially treated at best, and now it's fully treated to ENR, to enhanced nutrient removal. These nutrients were affecting the bay. You can see some algal blooms that you could see, some dinoflagellate blooms here, and some sea lettuce that was about 10 centimeters thick that would wash up on the beach right about there. So these photos are from this area called Bramble Bay. And so it was clearly starting to see some early signs of degradation. But the biggest problem happened in the late 1990s when these blooms of this, they called it mermaid's hair. It's a cyanobacteria, and it was causing the fisherman's skin to peel off, and very severe contact dermatitis. And we eventually did a bunch of science to sort this out, and we linked it to the fact that there was this clear-cut forestry that was going on for imported American pine plantations made to grow fiber quickly for the construction industry, and then a sequence of events with this clear cutting and rain, and then you can see the stream spewing out this very tannic water. What we did is we linked this clear cut, changing the water level. The lack of evapotranspiration from the trees meant that the water level came up, and it took the iron-rich soils, which were oxidized iron because of the lower water table, to reduced iron. And that reduced iron then came out with the humics and was a complex. And this humic complex delivered this iron, which was then disassociated with ultraviolet light, making it bioavailable for cyanobacteria. And that, with the nitrogen that they could fix with nitrogen fixation and the phosphorus that they could get from the sediments, meant that it stimulated this massive bloom. And and lots of environmental impacts associated with that. So as a result of the concern for this, the Lord Mayor of Brisbane and all the other mayors of local councils got together to create a Healthy Waterways campaign. This is a project that I was involved with the formation of, and a couple of my students diving there and collecting water samples. And we got a lot of kids planting stuff. We had this little toy boat, and because we're all in the same boat moniker, and we developed a very strong both research and management program in conjunction. And so for integration, we did a big fat, we did a conference which just got revisited 15 years later last November, and we produced your typical conference volume of 600 and something pages and tons of papers and black and white. But then we started producing a series of very popular, thousands of copies out of print now. They're all on the Ian website, of these little colorful booklets. And the first one was our first actual report card that we ever developed in that book with our conceptual diagrams and photos. And then, and this is only 100 pages, and this got to be and very inexpensive. And then we did this, pulled the science together with again using color graphics and everything to synthesize and integrate the science, but also generate specific recommendations for the way forward. So, and we did a series of 4 of these books, and a whole swag of newsletters and outreach events. We also embraced adaptive management with annual report cards, regular integrated assessments, the books, and we did. We divided the project up into these different components, and then had a management water quality strategy was the management outcome of that. We took all this data, synthesized it into a management set of strategies. And in terms of precautionary principle, the best part of our project is we initiated before the severe degradation was observed. You saw some algal blooms, but we really didn't have dead zones. We didn't have anything. In fact, the project was ongoing before that cyanobacteria bloom that caused the skin dermatitis with the fishermen. We essentially were anticipating population expansion because this was a really fast-growing area, and we got some of the sewage upgrades and water reuse initiated in anticipation of increasing pressures, and the Water Smart initiative of the Healthy Waterways started to embrace Water Smart City and use the water more efficiently, having the per capita water consumption. It helped that there was a big drought and there was a lot of pressure to do that, but it really became a much more water smart city. In terms of sustainability and resilience, it's gone through several changes of government, conservative, progressive, and in all cases they still embrace this project and the way forward. Resilience to climate change, that's a jury's still out on that. But one good sign was the response to a flood event. So the biggest flood of record of recent record was 1974, but then I actually turned up to go on sabbatical, and the next day the big 2011 flood happens. Like a dozen people lost their lives, but also inundated 20,000 houses. And it was a tremendously impactful flood, but the recovery from that was quite amazing, and the response of the community was overwhelming. They had the weekend after the flood, they had 20,000 volunteers out. They called it the Mud Army, going out to people's houses and helping them muck out the river silt that had built up and spraying it down, and people setting up barbecues and giving people, volunteers, free food. And then there was about half a dozen cases of looting. And I contrasted that to Katrina in New Orleans, where there were about 20,000 looters and maybe a dozen volunteers. So it really was a good response. For further reading, I wrote a chapter which I thought would be applicable for Moreton Bay, but also it compared Moreton Bay to Chesapeake Bay. So it's a good intro into some of the issues of Chesapeake Bay.